Good day, grade 7. I hope you are safe at home. So for today's subject, we have Mathematics 7. For today's lesson, so we're going to discuss about real numbers. So for today's lesson, we're going to discuss about real numbers. So class, what do we mean by real numbers? Okay, so when we say real numbers, so it is said to be any element of set R, wherein it contains the set of rational numbers and irrational numbers. As you will notice in our PowerPoint, I have here a schematic diagram of real number. So real number is divided into what do we call as the rational number and the irrational number. So when we say rational number, so these are the set of Q's wherein it can be written in the form of Q is equals into M over N, where M and N are integers, and N is not equals into 0. So this implies that a rational number is any number that can be expressed as the ratio of an integer to a non-zero integer. Since the ratio of an integer to the integer 1 is equivalent to the integer itself, then every integer is a rational number. So common fractions like 1 over 4, 2 over 5, and 7 over 3 are obviously rational numbers since their numerator and denominator are both integers. A negative fraction like negative 8 over 9 is also a rational number. It is equivalent to the ratio of negative 8 into 9. So it can be interpreted as the ratio of 8 to negative 9. So decimal numbers like 0.3, negative 1.1, and 2.5 are also rational numbers. These decimals are equivalent to the ratios 3 over 10, negative 11 over 10, and 5 over 2, respectively. So meaning to say, those are some of the examples of what we call as the rational numbers. While when we say irrational numbers, so these are real numbers, but it cannot be expressed in the form of M over N, where M and N are integers and N is not equals into 0. So, some examples of irrational numbers are pi. We all know that pi is approximately equal to 3.1416. Another example is square root of 2. Square root of 2 is approximately equal to 1.41. Another example, negative square root of 5. The negative square root of 5 is approximately equal to negative 2.236. So these are some of the example of what we call as irrational numbers. So using the schematic diagram, you will notice that under rational numbers, we have what we call as integers. When we say integers, so this can be decomposed into three subsets. We have negative integers, zero, and positive integers. And you will notice that zero and positive integers are under whole numbers. Why? Because zero and positive integer are said to be whole numbers. So, using this diagram, we're going to understand all about real numbers. So if you have any question about real numbers, you can ask your teachers. So we all know that integers can be plotted into real number line. So from real number line, so the following can be deduced. What do we mean by deduced? So it means concluded. So it is said that the integers increases its value from left to right. Meaning to say, the larger the number, the larger the value. The smaller the number, the smaller the value. And if we are talking about positive integer, remember that the smallest positive integer is positive 1, while the largest negative integer is negative 1. So, aside from the following, it is said that we cannot determine the largest or the least value among the integers. Why? Because there are said to be infinite integers or infinite number. That's why we cannot easily determine what is the least nor the largest value among the integers. And 0 is neither positive nor negative. So meaning to say, we cannot say that that is negative 0 or positive 0 because 0 is 0. All negative integers are less than 0. So, meaning to say, the value of negative number is smaller than 0. Then, all positive integers are greater than 0. So, meaning to say, the value of a number, if it is positive number, is greater than 0. So these are some of the things that we're going to remember about number line. So now, we come up into comparing of real numbers. So, in comparing of real numbers, remember that we need to apply the law of trichotomy. So, when we say law of trichotomy, it is said that if A and B are real numbers, so therefore, there is one and only one statement that is true. So, you will notice that we have here 3 statements. So, the first statement stated that if A is greater than B, or meaning to say, if the value of A is greater than the value of B. Second statement, if A is equals into B. So, meaning to say, the value of A is equals into the value of our B. And the third statement is that if A is less than B, or the value of our A is less than the value of our B. So now, let us have some examples about applying the law of trichotomy. So it is said that apply the law of trichotomy in comparing the following real numbers. So since we already know about integers, about real numbers, so let us apply what have learned about that. So for example, let us compare 4 and negative 4. So what do you think is the statement that is said to be true in our given? So, if you think that 4 is greater than our negative 4, so therefore, you are correct. Why? Because we all know, according into our discussion about real numbers and the real number line, so the number or the value of our integers increases from left to right. And of course, positive number is greater than negative number. So that's why 4 is greater than negative 4. Okay, another example. So aside from our given, so another example is square root of 3 and 3. So what do you think will be the statement that is said to be true in our given? So, we all know that square root of 3 is equivalent into approximately 1.732. So meaning to say, square root of 3 is less than 3. Okay? So, square root of 3 is less than 3. Another example aside from that is 0 and negative 7 over 10. So, if we're going to apply the law of trichotomy, 0 is greater than negative 7 over 10. Because we all know that all negative numbers are less than 0. Another example, 0.8 and 4 over 5. So, the decimal 0.8 is equivalent into 8 over 10 or 4 over 5. So, meaning to say, 0.8 is equals into 4 over 5. And that is how we're going to apply the law of trichotomy. Just remember that in applying the law of trichotomy, we need to remember also the things about the real numbers and about the... Okay, class, aside from that example, let us have another set of example applying the law of trichotomy in comparing the following real numbers. So for example, we have 6 and 10. Okay, so what do you think will be the statement that is said to be true in our given? So 6 is less than 10. Okay, correct. So why? Because we all know that the greater the number, the greater the value if it is positive number. Another example, negative 10 and 6. So, what do you think? Negative 10 is less than positive 6, correct? Because we all know that all positive integers are greater than negative integers. Another example, 0 and negative 1,000. So, 0 is greater than negative 1,000 because we all know that negative numbers are less than 0. And last example, 0.3 and 3. So what do you think will be our answer? 0.3 is less than 3. Okay, because we all know that 0.3 is equivalent into 3 over 10, while our given is 3. So 0.3 is less than 3. Okay, that will be the example about applying the law of trichotomy. I hope you learned a lot about this. Okay, class, so thank you for listening about our discussion. So I hope you are stay safe at home. Thank you and Laos Deo.